Hello everyone, my name is Anggit Raksajati. In this video, I'm going to present you the overview of Chemical Process Design course. So this is the code, class arrangement, and lectures for all three classes. The content of this video is mainly applied for KO1 and KO3 under myself and Pak Tripartono Adi. So the outcomes of this course is to provide knowledge and understanding of the synthesis sequence of industrial chemical processes. You have to be able to explain the process design hierarchy based on the onion model, and then you have to be able to design reaction flow systems, separation methods, and heat exchanger networks for a process. And then the student must be able to analyze a process with consideration of reactions, separation methods, separation tools, and heat exchanger networks based on cost, acquisition, selectivity, conversion, reaction type, and physical chemical properties of the feed and the products. And then the student has to be able to evaluate reaction flow, separation method, and heat exchanger network of a chemical process. The syllabus of this course will be mainly covering 7 topics, which will be applied in several case studies. The first one is to design a process in the engineering of a chemical plant that includes iterative style of process design and process innovation pattern. And then the second part is about the synthesis of reaction paths, including the molecular synthesis strategy, the selection of the reaction path, reaction flow chart by recycling. The third part is about the reactor selection. We will talk about the type of reactor, such as a plug flow reactor or the CSTR, and then the reactor performance is ideal, and then how to optimize operating condition of the reactor, and then the reaction phase, whether that's a homogeneous or a heterogeneous catalyst, and then the selection overview. The fourth topics will be about the selection of the component separator. If it's a homogeneous mixture separation, maybe we will talk about some distillation, for example, but if it's a heterogeneous mixture separation, maybe we will have to include some kind of filtration and etc. And then we will talk about some tools and then some hierarchy and rule of thumbs and heuristics for distillation and absorption, dryer and evaporator, and then the selection overview for a separator. Fifth topic will be about synthesis of structure and process flow diagrams, how to make a one-time processing structure, a material recycling function, steam and liquid recycling, the party process or a batch process, acquisition of a process, and then overview of a process structure, including how to integrate it in a process simulation. And then the sixth topic will be about the design of utilities and heat exchanger networks. That comprises of how to make composite curves and program tables manually and also using software engineering tools. And then we will talk about some constraint, utility selection, and cogeneration in terms of the heat exchanger networks design, and then how to minimize the displacement surface area and the total cost and etc. And then the overview of the design of the heat exchanger network. And last, we will talk about process optimization, structural or parameter optimization. For example, optimization for reactor, process ablutions, and party processes. Again, in terms of the method for the course, we will use a lot of simulation, such as Aspen Plus and HYSYS. Therefore, we will have a lot of case studies instead of conventional teaching or traditional classes. So at least there will be 5 cases. The first one is about the dimethyl ether synthesis from methanol. We will talk about that in the first 3 weeks, starting from the basic concept, the basic process, how to make the PFD, and then how to start the simulation process, how to solve the heat and material balance using the simplified or the shortcut equipment, and then continue with the rigorous equipment design, such as the rigorous reactor, rigorous distillation, and then the heat exchanger optimization or heat integration. And then in the next 2 weeks, we will have a case study of a synthesis of acetone from isopropyl alcohol. And then in the third case study, we will talk about some condensate extraction or a natural gas liquid, a heavy hydrocarbon separation. And then the fourth chapter will be acid gas removal unit using alkanoamines mainly. And then the fifth topics will be about heat integration network. And then at the later part of the course, we will incorporate your plan design final project, mainly the report 1 and report 2, which is the definition of basis of design and then the conceptual design. So please be prepared. You will have to finish most of the outcomes of this course by about week 10 or 11, so that you will be able to apply that for your plan design. The reference, mainly it's from Robin Smith, Chemical Process Design and Integration, but we will also use some supplementary reference such as Analysis, Synthesis and Design of Chemical Process by Turton, Conceptual Design of Chemical Processes by Douglas, Systematic Methods of Chemical Process Design by Bigler, and Process Design Principles, Synthesis, Analysis, and Evaluation by Cedar. And maybe we will give you some other supplementary reference, for example, some tutorial about the simulation, etc. The software, mainly we will use Aspen Plus and Aspen HiSys, at least V10. But if you already have the V11, that's fine. Supplementary, we will use Microsoft Excel for some calculation. Rule, task, and assignment. Follow the academic rules set by ITB, including the attendance limit. And then watch the tutorial video before the class session. And you have to build the simulation each week according to the next video or tutorial. Please be mindful that the course session will be mainly used for discussion. We don't expect you to build the simulation during the class session. Why? Because it's too risky. Risk of lack of online or connection, and then risk of software technical problem. So it's much better if you already built the simulation before the class. If you have some problem, you can consult with the lecturer and or even the assistant, and then we can have a more advanced discussion during the class session. If your personal PC or laptop couldn't support Aspen or HiSys, you can use the PC at LabTech or in X233 room through remote desktop. Please contact Pak Indra from SKTK to help you about the PC booking for each week. You can also book the PC a part of the course session. So let's say the class will be on Friday, you can book the PC on Thursday night or Wednesday night, as long as it's available. And you can ask the lecturer outside of the class using WhatsApp group or any other convenient media. In terms of the assignments, we don't have any exam. We will have mainly 3 group projects for you to be graded for your final assignment and for your final mark. Okay, so that's the end of the first video. See you on the class.